Hi! So this image is going to show you the different stages that stars go through as part of their life cycle. And the thing that you should know is that everything that ultimately ends up happening depends on the initial amount of material that's available to form the star. So it starts here, goes here, and then takes one of two paths depending on that initial mass. The first stage is the nebula. And so the nebula is this starting point of gas and dust and materials that are coming and collecting together. New stars are forming in this dusty molecular cloud of the Lagoon Nebula. If there's enough material to come together, it starts, gravity then will pull it together. Then you're going to get something called a protostar. Proto means before, star, so protostar. Protostar HH34 is here in the constellation of Orion. So this is a protostar. After that, you're either going to have a path here or a path here. This upper path is a path that would be taken by a star that is similar to our sun. So here's the main sequence of that star. This would be a massive star's path here. So the main sequence starts here. This is the sun, a typical main sequence star. You can see that there are a few sunspots on the image that's shown here. Stars with less than 8 solar masses, you're going to see something that's a red giant. So here's the red giant Mira in the constellation Cetus. Then you're going to see a planetary nebula after that. So at this point you're having fusion occurring in the center of the star. And then you're going to see that once the materials, the red giant's expanding, it's cooler than the main sequence star. And as it's expanding, these outer layers are going to start going away, and you're going to get a planetary nebula. People refer to these often as God's eyes. And so you'll see here's the planetary nebula. This in the center is a white dwarf. Here's the outer layers that as they're leaving the star. It's called a planetary nebula because when they were first observed in the night sky, astronomers thought that they were actually new planets, similar to Saturn, that had maybe rings going around them. So the name stuck. It actually has nothing to do with planets. Well, generates materials that then ultimately make planets. So maybe in some way it indirectly has to do with planets. This is the Eskimo Nebula in Gemini. And then once those outer layers have shed and kind of gone off into space, you're going to have just the white dwarf left. So here you can see several white dwarfs in the globular cluster M4. So there's a way of cataloging different objects in the sky, and one of those systems is the Messier catalog, developed by Messier. Now if you have a massive star, you're going to come down here and you'll see this. This is the massive star in the Pistil Nebula in the constellation Sagittarius, the largest star known. Then you're going to go on to a red supergiant. Sometimes you can have things like a hypergiant here would be above a supergiant. This is the red supergiant Betelgeuse in Orion. So you'll notice when you start seeing this at night, this fall winter, that it is red to your naked eye. After that, it's going to go supernova. This is the Crab Nebula supernova remnant. It's beautiful. And all of these attributions you're going to see are different telescopes and agencies that were involved in capturing these images. And then that mass comes into play again. So if these are all stars with 8 solar masses or more, and if it's 8 to 15 solar masses, your end result's going to be something called a neutron star. Sometimes we can get pulsars from these if these neutron stars are spinning rapidly and there's light emitted from them. The neutron star here circled in this constellation, and I cannot pronounce its name, Ophiuchus. So this is from NASA, Chandra's the telescope, and then this is the scientist. So if it's got more than 15 solar masses, that's when we're going to end up with a black hole. And you're going to see that there's this bright flash marked by an arrow in an X-ray flare, evidence for the black hole near the center of the Milky Way galaxy. You'll be learning this week that most of the time we're looking for things around the material that's around the black hole behaving in a certain way, and that's our evidence that a black hole exists there. So that's your life cycle of a star in a nutshell.